Hello friends, welcome back to EMRS Nasik. This is our sixth lecture on the chapter matrices, and in this lecture we are going to see inverse of a matrix by using elementary operations. So we are going to see inverse of a matrix by elementary operations. In previous lecture we have seen what do we mean by invertible matrices. When we say that two matrices are invertible, just take a look of what we have studied earlier. Suppose I am given a matrix A, which is a square matrix of order n. Then when this matrix A is invertible, this square matrix A is invertible if there exists another matrix B of the same order, means both A and B are the square matrices of same order, and then if AB is equal to BA is equal to identity matrix. Okay, I is the identity matrix. If this multiplication AB and BA comes out to be the identity matrix of same order, then we will call B as a multiplicative inverse of A. Okay, then we will say that B is the inverse of A, and we will write this as B is equal to A inverse. Similarly, here also BA, this multiplication comes out to be I, then we will say that A is inverse of B, and we will write this as A is equal to B inverse. Now in this case we say that A and B are invertible matrices. Now the question is how to find these invertible matrices, and in this lecture we are going to see how to find the invertible matrices by using elementary operations. Now we know that we can perform only 6 types of elementary operations on a given matrix. So by use 3 along rows and 3 along columns. So by using the elementary operations we are going to find the inverse of a matrix. In order to find the inverse of a square matrix, there are few steps. First, write that matrix A as A is equal to IA. Second, perform the elementary operations on the both sides of this equation A is equal to IA. Okay, so perform some elementary operations on the rows or columns of the elements of matrices on the left hand side and the right hand side. After performing the operations, you will come across this relation I is equal to BA, means perform these operations, elementary operations, until we reach this matrix A to I and this matrix I to B, and when you reach to the identity matrix on the left hand side, at that step stop doing elementary operations. But when you are going to perform these operations, your A becomes I, at the same time your identity matrix becomes A, and then I will say that the multiplication of B and A matrix is identity matrix. That implies B is the inverse of matrix A. Okay, make sure that while performing the elementary operations, if one or more rows or columns becomes 0, then in that case A inverse does not exist. Now we will see how to find the inverse of 2 by 2 matrix. Means you will write first that matrix A is equal to IA. Then you will perform some elementary operations in order to reduce this equation as I is equal to BA means you are converting this matrix A into I. You are converting this matrix A into I, and at the same time this I will be converted into B. So there are maximum 4 steps that you have to follow. And which are these 4 steps? C means that matrix A, we have to convert that matrix A into identity matrix, means first we have to convert first element as 1, then second element as 0 here, third element this as 1, and fourth element this as 0. So there are 4 steps. There are 4 elementary transformations that you will perform in order to convert this matrix A into identity matrix. So what is your first operation? Your first operation will be to convert this element as 1. Then your second elementary operation will be like this, so that this element becomes 0, and your third elementary operation will be like this, so that this element will be 1, and similarly your fourth elementary operations will be like this, so that this element becomes 0. So if you are given a 2 by 2 matrix, there are at most 4 elementary transformations you can perform. Now consider the example. Suppose you are given one 2 by 2 matrix and you are asked to find the inverse of that matrix by using elementary operations. So when you are going to use the operations, use either row operations or either column operations. So this example this is 2 by 2 matrix. So first step, what you will do, you will write this A matrix as I times A. Okay, then this will be A is equal to I times A. I is the unit matrix, identity matrix of order 2. Now, so by saying this, I can perform at most 4 elementary operations. First operation is to convert this element as 1, but it is already 1 is there, so means already this operation has performed here, means now we have to perform next 3 elementary operations. Now my next objective will be, I have to convert this 2 as a 0. So for that purpose I have to perform some elementary operations. So if I perform R2 goes to R2 minus twice R1, means the elements of second row will be converted as second row elements minus twice first row elements. So what will happen, we will see. Okay, so second row element means 2 minus 2 times first row element is 1, so 2 minus 2 times first row element is 1, so 2 minus 2 gives me 0. Similarly here also R2 means 3 minus 2 times R1 is 2 times R1 is minus 1, this gives me 5. So the same kind of transformation took place on right hand side. So this is R2 is 0 minus 2 times R1 is 1, so this will give me minus 2. And here also R2 is 1 minus 2 times R1 is 0, that is, this gives me 1. And I will keep A as it is. Okay, so the changes will took place in second row only, so first row elements are same. So after performing this operation, these matrices reduces to, okay, so second row elements will be 0 5, okay, on RHS second row elements will be minus 2 1. Now my third objective, my third step will be, I have to bring this element as 1. So what I will do, I will simply Okay, what I will do? I will do simply divide this second row elements by 5. 0 by 5 gives me 0, 5 by 5 gives me 1. So my third elementary operation will be what? R2 goes to 1 by 5 times R2, means the second row elements will be multiplied by 1 by 5. First row will remain the same. Okay, so after performing R2 goes to 1 by 5 R2, what will happen? The elements of second row will be multiplied by 1 by 5. So this will give me only 0. This will give me 1. Here what will happen if I multiply by 1 by 5? This will give me 2 by 5 and this will give me 1 by 5. So the matrix will be like this. Okay. Now next step is I have to perform that kind of elementary operation so that these elements become 0. Why this element should become 0? If this element is 0, then LHS will be your identity matrix. Okay, so the changes took place in first row. So I will perform R1 goes to R1 plus R2. Here make sure that if I add R1 and R2, the changes to what are the changes? Changes took place in first row only. Second row elements will remain the same. What will happen? R1 plus R2, 1 plus 0 gives me 1, minus 1 plus 1 gives me 0, 1 plus minus 2 by 5 gives me 3 by 5, and 0 plus 1 by 5 gives me 1 by 5. So the elements of first row will be changing and elements of second row will remain the same. So this will give me, okay, this matrix. Now if you see, your LHS is identity matrix and your RHS is some another matrix. Suppose I will call this as B and A. Okay, so your LHS is I means identity matrix of order 2, your RHS is another matrix B suppose, and this is matrix A. So I will write this as I is equal to BA. So the multiplication of these two matrices is identity matrix, means both are inverses of each other. So B is inverse of A. So B is inverse of A. Okay. So by using these elementary operations, we have found the inverse of 2 by 2 matrix. What happens if you are asked to find the inverse of 3 by 3 matrix? Again, what you will do, you will write I is equal to A is equal to IA. Then you will perform some elementary operations and you will convert I is equal to BA. Okay. So while converting A into I, how many A into I means identity matrix of order 3 by 3. So how many elementary operations you will perform there? Of course, 9 elementary operations. So your first operation will be to convert this element as 1, then these two elements as 0. So these are the first 3 operations. Your fourth operation will be like this. This element is to be converted as 1. This is your fourth operation. Fifth, sixth is your choice. Seventh will be, this element should be 1. So perform that kind of elementary operations so that this element will be 1. And 8th and 9th is your choice. Okay. So in next period we will see how to find the inverse of 3 by 3 matrix. Thank you and have a nice day.